Kia ora. Yes, we're recording. So today I'm going to go through the solutions, well, my solution for the covered pool task. So first things first is we're going to have a quick look at what achieved merit and excellence are. So you've got to remember that we're doing two internals. We're doing the trigonometry and we're doing the coordinate geometry. So to be able to get an achieved in each of them, you need to show 2 to 3 skills of that standard. So an example with that would be if you wanted to get an achieved in the trigonometry portion of it, if you just use 3 of these formulas correctly and it's useful for the problem that you're solving, then you'll get an achieved for trigonometry. Right? If you use then 2 or 3 formulas from the coordinate geometry section, that will get you an achieved. So for example, let's say that you find a distance between 2 points and then you find the gradient between those 2 points and then you use the gradient to work out the distance between those 2 points. That will get you an achieved in the coordinate geometry, so you'll get your credits. Same goes for trigonometry. Use cosine once, use sine once, and then find the area of a triangle. That will get you an achieved. To get a merit, that's when you start. How do I go down on this? I think it's like this. To get a merit, it's when you start getting the solutions to these overall questions. And when you're going for an achieved, you need to be working towards that solution as well. You can't just sort of pick random points and work them out. They have to be in context. Right? So when you start solving these tasks, that's when you get a merit. And then pretty much excellence, we can't really tell you what excellence is going to be because excellence requires some outside of the box thinking, and it should do for most of NCEA. But usually it's showing abstract thinking, doing some sort of reversed algebraic solving, or some real life problem solving. So in this question, excellence looks like it's going to be finding... I don't actually know if this question goes to excellence. I imagine this is maybe doing all of the stuff perfectly will get you an excellence in this one. Let's just make that assumption. So what we're going to do is we're going to start and we're going to work out a strategy for solving this. Now I want to grab this thing and it is not... I'm drawing, whoopsies. Okay, so what we're going to do is I'm going to make this thing grab for me. So I'm going to grab this and I'm going to make a big ass version of it so that we can have a little look and start doing some problem solving, and we'll just sort of draw on it as we go. So the first question is asking us, calculate the perimeter of the covered pool. So I'm going to tell you what I've defined the things to be. So to me, this here, this is the cover, and the cover is the whole orange bit, right? And then as far as pools are concerned, this is going to be pool number 1, this is going to be pool number 2, and this is going to be pool number 3. Right, so the question is, let's go back up and have a read of it. Calculate the perimeter of the covered pool. So what we're going to be trying to do is working out what this perimeter is. So we're going to have to work out going up here, then we're going to have to go over here. So as you probably know, perimeter is the length around an object. And then we're going to go down here and we are going to go across here. So that is what we're going to be trying to solve. So in order to do that, we're going to need to find the distance, but it's not the distance right up to H, it's only the distance to this point, and we haven't actually got a name for this point, right? So this point here is an intersection. So I'm going to do a big dot on this one, because we're going to need to know for a perimeter of this pool, we're going to need to go from D to whatever this point is. So we're going to have to come up with a name. So A, B, C, D has been taken, so has E, and so has H. Also, because we're dealing with coordinate geometry, X and Y are sort of already been used. So I would probably go for M. And then we're also going to have to find this one over there because it's part of the perimeter as well. So I'm going to name it N. Now you could name that whatever you want, but these are just letters that I picked just because I like them. Okay, so we're gonna do a strategy first. So rather than actually doing the maths, we're gonna come in and like think, how are we going to do this? So we're gonna need to find the distance between D and M. Distance between D and M. But how are we gonna find a distance? We need to know where this coordinate is first. So it looks like we're going to be using coordinate geometry, but to find a point that we don't know anything about, we're going to need to find an intersection, right? So I'm going to start brainstorming. So I want to know, what is M at? So M's going to be some coordinate, x1, y1, but we don't know where it is. So in order to find that, well, we can see here that M is at the intersection of D and H. So I'm going to call that the line YDH. And it's at the intersection of YDH and also YAB. So it's going to be where YDH equals YAB. So that's where we're going to find the point M. So in order to find YDH, how are we going to find that? Well, we're going to need to find the gradient of DH, and then we can just substitute in any point. So maybe we'll substitute in point D. So we're going to have to use the gradient and D. That would help us find this. And then to find YAB, we're going to need to find the gradient between A and B, and then we're going to have to use a coordinate with that as well. So maybe we'll use A. A looks pretty easy. So this is like my strategy that I'm coming in with. So that will only find me M. Once I've found M, then I will be able to say what is the distance between D and M, right? Because I will have a coordinate M and a coordinate D, so I'll be able to apply that formula. So let's go ahead and get started doing that. Well, actually, we'll just finish off the strategy, right? We'll be able to work out that distance, but then to work out this distance here, we are going to need to know what is coordinate N. So N is going to be much the same. It's going to be something real similar to this. We're going to need to find YHC, and we will already have YAB, right? Because we would have worked it out from this one up here. And then we're going to have to do pretty similar steps. So along the way, we're going to end up using finding a gradient. We're going to end up using finding a distance. We're going to end up using finding an equation, and we're going to end up using solving an equation to find an intersection. So to me, that's a coordinate geometry merit. So that's what we're going for with this section. Okay, so what we're going to do is, let's start off by finding DH. Let's do some stuff with DH. So maybe it's worth putting a title here. So I'm going to say finding perimeter of covered pool. It's just so the marker knows what I'm talking about. You have to, oh man, I'm going to be able to draw a straight line better. Yes. See that little bit on the edge there? That's Mac lag right there. What I'm going to do to do this nicely so I can keep referring to it is I'm just going to grab another, oh, come on. I'm just going to grab this. Take me in text mode, give me that. No. Okay, I guess I'm using this. Copy that. And bring it down here for you guys. So then we can keep referring to it. Okay. So what we need to know is what is D. So we're going to try, we get D equals -5 and 1. And we know that H equals, oh man. Don't buy a MacBook Air, because it can't handle a drawing pad, even when it's plugged in. Okay, so we've got these two coordinates, and we can use these two coordinates to find a gradient. I don't know how I could possibly make my computer run any faster than it's running. Okay, so we're going to go gradient of dH. So to find the gradient, we may as well just refer to our formula. So the formula's here. We just do y2 minus y1 over x2 minus x1. Sweet, easy as. So this is going to be my y2. This is going to be my y1. This is going to be my x2. This is going to be my x1. So then that's going to be, I have to go a bit lower because I'm writing messy. So it's going to be 7.29 minus y1, 1 over negative 1.14 minus negative 5. Right, make sure you get these negatives right. Okay, so am I going to use Google Calculator or a calculator? So the way I'm going to type that into my calculator is it's a fraction, so I'm just going to make sure I do a bracket on the top and a bracket on the bottom. So I'm going to go bracket 7.29 minus 1, close bracket, the fraction symbol or divide symbol, over, open a bracket, negative 1.14 minus negative 5, close bracket. So it looks a little like that. Click enter, and that will be my gradient. I'm going to click F to D just to see if it's beautiful. It's not beautiful. I'm going to stick with the decimal. Lots of people are asking me about rounding. I like 3dp. So just, yeah, whatever. So that's going to be, so it's 1.6295. So I'm doing that 3dp, so it's going to be 1.630. The main thing with rounding is just be consistent and don't go too small. Like some people doing 1dp, and it's going to just throw you out with rounding errors. So we've got a gradient here. Once you found a gradient, you're nearly, like you're on your way to getting it achieved. So now that I've got that gradient, let's use that in the formula for a line. We'll use that in the formula for a line. So we've got up here, an equation is y minus y1 equals mx minus x1. I'm going to write that out fully so that you can see what I'm doing. Y minus, oh, so much lag, it's blowing my mind. Y minus why lagging equals, oh, this is tough, m x, oh, we're back on. Okay, so this is the formula. These here, I just picked the one that's easier. See how this has got like nasty decimals? I'm always just going to pick the one with whole numbers. Right, so I know that y minus, and what's y1? It's 1. Equals, what is the gradient? It's 1.630. I don't even need the 0. I'm just going to get 1.63. And then x minus, and what's x1? Negative 5. So we're going to need to do a bit of algebra to like tidy this up. So we're going to end up with, I shouldn't do too many steps at once, but I'm going to do lots of steps at once because why not? 1.63x, and then I'm going to need to do 1.63 multiplied by negative 5. So what's negative? Negative is just positive. So I'm going to go on my calculator and do this. 1.63 times 5. So I'm typing into my calculator. So that's 8.15. Oh, that's a nice number. 8.15, and then see how I had minus 1 over here? So that means I'm going to have to add 1 to both sides. So I'm just going to add 1 onto this number here, plus 1. Notice that I added 1 after I did the multiplication because this is like on the outside of the bracket. So that's going to be plus 9.15. So this is now a formula that my points follow. So now I've got the equation of a line. I'm actually going to label it. So what is this y? This is y dh. That's what I'm finding. I'm finding this line here. So now I found the gradient of this line, and I now know the formula for that gradient. So I'm just going to label it as y T. Oh. Come on. H. I reckon a Chromebook might run this faster, to be honest. All this computer is doing right now is doing an OBS screen record and running OneNote and a tablet, and it cannot handle it. It's only a $2,000 laptop, people. Okay, so we found the equation for this line. So now we're going to need to find the equation for this line here. So that's AB. So we're going to go gradient A. Oh. I feel like I'm stuck in like the years of dial-up internet. That's what it feels like to me. Okay, AB. So this time I'm not going to draw the coordinates because I'm sitting up here, so I'm just going to do them direct. Sometimes it's nice like separating your work so you can see that what was happening over there is like different to what's happening over here. Kind of nice. Okay, so MAB. So I'm gonna make that the 2's and I'm gonna make that the 1's. So Y2 is 6, Y1 is 5. Y2 minus Y1 over X2 minus X1. Nice. Oh, I can do that in my head. 6 minus 5 is 1. 1 plus 7 is 8. So it's 1 over 8. So that's 0.125. That's 3dp as it is. Beautiful. Okay, so then to find the formula for that, I'm going to skip writing out this. Might do it in a different color just to so we can see. So it's going to be y, and I picked the one that's easiest coordinate. Actually, b's the easiest coordinate there. So I'm going to go y minus y1 equals 0.125 x minus, and then x1 is 1. Oh, yeah, this is easy to work with. So it's going to be y equals 0.125 x, and then I'm going to do 0.125 times -1, convenient, and then it's going to be plus 6. So it's going to be minus 0.125 plus 6. So that means that YAB is going to be 0.125x, and then 6 minus 0.125 is 5.875. I just want to double check. Yes, 875. Nice. So we've now got these two equations. What I'm going to do is I'm going to color them in for you. I'm going to attempt to anyway. So we've got the blue one going, no, I'm trying. Blue one's going, what angle? This angle. Pretty good. We've got the blue one going there, and we've got the green one going along here. So therefore, they intersect here. And we can find that intersection by setting these two things equal to each other. So that's what we tend to do in maths. Okay, so what we're going to do... Oh, look at that. Goes right over it. Beautiful. Okay. So what we're going to do is we're going to say let YDH. We're pretty much saying when does YDH equal YAB? Right? And so what we can do is we just know that YDH is equal to this, so it means that 1.63x plus 9.15, because we know YDH is equivalent or equal to that. So what is YAB equal to? Well, it's equal to this thing over here. 0.125x plus 5.875. Oh, this thing's finally keeping up with me. This is great. Okay, so what I do is I find out which side has the bigger x. So this side's got bigger because it's got 1.63. So I'm just going to drag all my x's over to that side. So I need to minus 0.125x, And then if I'm doing it on that side, I need to do the same on this side. 125x. And then I want to get rid of this. So I want to do that in red. So to get rid of that, I'm going to go minus 9.15. So I pretty much put all of the numbers without an x coefficient on one side, and then I put all of the things with an x coefficient on the other side. So if I've minus 9.15 there, I need to minus 9.15 here. Yeah, so let's see what happens. Am I at the stage where I should probably stop trusting my brain and go to calculator? Yes. 1.63 minus 0.125. So that's 1.505. Oh no, I'm going to go 1.505x. Make sure you bring that x with you. And then these things are going to cancel each other out. These things are cancelling each other out. So then what's left on the right hand side, it's going to be 5.875 minus 9.15. So that comes out with a negative, and that is negative 3.275. We're not quite done because we need x by itself. So to get x by itself, we need to divide by whatever's in front of it. So we're going to divide by 1.505. If I'm dividing by that on that side, I need to do the same thing on this side. Oh shucks. Oh shucks. What am I doing with my life? There we go. So as we usually do, these things cancel out. So we're just left with the x. Beautiful. And then over here we've got negative 3.275 divided by 1.505. So that gets us negative 2.176. That's 3dp. What I like to do at this point is I go up here and I'm like, does that logically make sense for that coordinate to be negative 2.176? So let's have a look. Would it make sense to have negative, so given that this is negative 7 and this is 1, do you think that that coordinate's around about negative 2? And I think, yeah, it makes sense because negative 2 is between negative 7 and 1, and it's closer, the intersection looks closer to this side. So yeah, that makes sense that that would be the answer. I mean, I could have made a mistake, and I have no real good way of checking that, but yeah, it looks good to me. Now that we've got the x coordinate, we just choose one of these equations that's easier, and we just substitute this into the equation to find out the y value. So this one on the right actually looks easier to me. So then I can say that y will be equal to 0.125, and then in brackets I'll just substitute what I know x to be now, plus 5.875. And so I'm going to type that into my calculator. It looks a bit too hard for me. My puny brain. 2.176 plus 5.875. It looks good. So y comes out at 5.603. I should have really had like a student's work here rather than just doing it on the fly. So that means that I've got the coordinate now. So that means I've got my, so then what was it was called m. So m is now going to be defined as negative 2.176, which is my x, and then 5.603, which is my y. Let's see if that makes sense for 5.6. Does that seem logical? Given this is 7.29 and this is 1? Yeah, 5.603 seems pretty logical. So now that's my coordinate m. Now if you got this far, you've already got achieved. But really, finding the perimeter, all we've done so far is we've found this point M from our point D. What we still have to do is we still need to find N, and we need to take N down here to C. So all we've done so far is found out what this coordinate N is. So the reason this helps is now we can find the distance from D to M. And yeah, because we know that D is negative 5 and 1, people are rumbling around, which means I think I'm nearly done. Okay, I've got 5 minutes. Okay, I'm going to try and quickly find this distance. So the distance from D to M is, we're going to use that formula up here. Remember, always just use your formula. X squared, x2 minus x1 minus plus, or squared, plus y2 minus y1 squared, all square rooted. Okay, sweet. I'm going to do that all in one go if possible. So I'm going to go, what's x2? I'm going to call m my 2. So this is going to be my x2, y2, and this is going to be my x1, y1. So then I don't even need to think, I just plug things into the formula. What was it? x2 minus x1, right? Yeah. Negative 2.176, and then minus negative 5, all squared, plus 5.603 minus 1, all squared. Now, when I'm doing this in my calculator, it means I'm going to need to do a square root symbol. I'm going to need to open a bracket, and then I'll blah blah blah, put all my stuff. I'll then close the bracket, square it. Ooh. I'm going to then go here, open a new bracket, square it. Now, my calculator is going to just square root this front bit unless I put another bracket here and another bracket here. So that's really important that that's how I lay it out on my calculator. So I'm going to go square root, bracket, negative 2.176 minus negative 5, close the bracket, square it, plus, open a new bracket, 5.603 minus 1, close that bracket, square it, close that bracket off, and then that should get me my answer. So the distance comes out at 5.4, and the fact that there's 2 zeros after that makes me pretty confident that that's the answer. But now that I've said that, I've lost all my confidence, because you should never be too confident about anything, right? So distance is 5.400, and that's the 3dp. Has she specified that it's in meters? No, she hasn't. So actually we have to just say units. Is it squared? No, because it's just a distance. So pretty much now we know that this is 5.4 meters. I mean, let's be honest, it's meters. All right. You're then going to do the same process as what I did. You're going to find the intersection between here and here to find your point N. You'll then do a distance formula from M to N. You'll then do a distance formula from N to C. And then you'll do a distance formula from C to D. And then you'll add those together to say overall perimeter is how many meters? Probably like 30 meters or something like that. Maybe like 25 meters. And that will get you a merit for coordinate geometry. Otherwise, that's all for now. I'll do a part 2 for this video at some stage.